All right, it is 1 o'clock, so we're going to go ahead and get things started. Welcome, everybody, to our second virtual field day of 2024. My name is Mitch Harding, and I am a water outreach specialist with Iowa Learning Farms. So, a little bit about Iowa Learning Farms. We were established in 2004 with the goal of building a culture of conservation by working with farmers and researchers to help implement practices that help build soil health and water quality while remaining profitable. So we do this with many partners, which include the Iowa Department of Ag and Land Stewardship, USDA Natural Resources Conservation Service, Iowa State Extension and Outreach, the Leopold Center for Sustainable Agriculture, Iowa DNR, Conservation Districts of Iowa, the Iowa Farm Bureau, Practical Farmers of Iowa, Growmark, the Iowa Agricultural Water Alliance, Iowa Corn, and the Iowa Nutrient Research Center, and the Sea Change Project. So just a reminder, if you have any questions throughout the presentation today, go ahead and put those in the chat at any time. Also, you'll be invited after the videos if you would like to ask a question face-to-face, I guess, with Michelle or Billy. Go ahead and ask me and I can unmute you so you can ask them directly. Also, we are going to be sending out an evaluation this afternoon. Please go ahead and fill that evaluation out. That will help us for future events and future virtual field days. So please fill out that evaluation. Otherwise, today's virtual field day, we are going to be led by Michelle Superior, a professor of agriculture and biosystems engineering here at Iowa State, as well as Billy Beck, assistant professor and extension forestry specialist with Iowa State Extension, to explore different types of wood chips being used in bioreactors, as well as improving woodland management options for farmers and landowners to promote health and resilience of forested areas. So without further ado, I'm going to go ahead and get our first video started. Again, if you have any questions throughout the presentation, feel free to put those into the chat.
Hi, I'm Billy Beck, Extension Forestry Specialist with Iowa State University Extension and Outreach, and also Assistant Professor in the Department of Natural Resource Ecology and Management at ISU. I have the distinct pleasure to be here with Dr. Michelle Sapir, ISU ABE, and we're traditionally not very close partners, engineers and foresters, but today we're going to be talking about a very exciting project that is combining the two fields to hopefully improve water quality, but also forest health around the state of Iowa. Michelle, thanks for hanging out in the woods.
Hey, thanks for inviting me out here, Billy. So today we're going to talk about the connection. So what do ag engineers and forestry specialists have in common? And it's wood chips. We do a lot of work with wood chip bioreactors, and we're really excited to partner with Billy and his team to learn more about what kinds of woods and how can we chip these woods more efficiently to provide the wood chip resources that we need to get more wood chip bioreactors installed across the state of Iowa to help clean drainage water before it discharges into streams. So Billy, do you want to talk a little bit about some of the different types of woods we see out here and what our opportunities are to get some more of this wood into wood chip bioreactors?
I would love to. But I have a quick question first for you, Michelle. We have wood chips already, so why study different species and can you enlighten us on that?
Yeah, actually, we have wood chips available through a couple of vendors, suppliers in the state. Actually, only about 2 official suppliers can provide wood chips to bioreactors. And when we look at the number of tile drainage outlets that could be treated with a bioreactor and our goals to meet for the nutrient reduction strategy, we estimate over 100,000 bioreactors could be installed to help clean up the water across the state of Iowa. So first of all, we have a very limited number of places where we can actually source those wood chips. And then there's also some challenges as far as the size of the wood chips that can be installed into the bioreactors. And so we really want to explore different options, kind of an all sources approach. How can we find more wood? Can we consider different types of wood? Could we consider smaller wood chips? Could we consider woods that have been shredded with with different types of grinders. And so we have a new project to look exactly at these things and then to try and monitor over time to see how these wood chips perform. But the first part is, where can we find these more diverse wood sources that we're looking for?
Yeah, we've fortunately got one right here, and this is a hackberry. It's a great tree. It's got a beautiful white wood. It's great for pollinators. It has a stone fruit in the fall that's actually edible, but wildlife love it as well. But this is a really good example of why the project is relevant and why it's occurring. So I'll start off by just defining two quick forestry terms for you all today. The first one is forest succession, and that plays a big role in how we manage our forests across the state of Iowa. Succession in forests, well, first off, forests change over time, and they change in species composition and structure. So by structure, I mean the physical layout of the forest. Now that change over time is driven by disturbance. So things like fire, bison grazing and elk grazing historically, all kinds of things that we do in the forest, disturbance, wind and ice, the derecho from 2020, that all influences the species composition and the structure of our woodlands. So disturbances are actually quite beneficial in woodland management, and as foresters we mimic natural disturbance to achieve our management goals. However, when we take a lot of disturbance out of the equation, we really limit the amount of sunlight that hits the forest floor. And that is really impactful for species that need sun to regenerate, like black walnut and oak, which are the backbone of our forest products industry in the state. They also have a huge wildlife impact, a huge recreational impact, just very, very important species in our state. So with no disturbance or minimized disturbance, we see a lot of shade-tolerant species building up in our forest understory. Now, shade-tolerant species like this hackberry here, and species like basswood, hickory to some extent, they can photosynthesize at a higher rate in the shade. They don't love shade, but they can photosynthesize at a higher rate in the shade. So they get a leg up on regeneration from oak and walnut. So when there is a disturbance or a derecho or some kind of ice storm, these are waiting in the wings to take advantage of that new sunlight. So these are what we call late successional species, these shade-tolerant species like hackberry that build up and wait for a canopy gap to open. So the link to forest health is these are building up rapidly in our woodlands across Iowa because most of our woodlands are passively managed. They're not actively managed working with a professional forester. So we have a great deal of these species building up in our understory that need to be thinned out to promote species like oak and black walnut. These are very valuable species. We're not saying to go and remove these from our woodlands. However, their prevalence and their successional path is threatening our oak resource to some extent. Great species, they just need to be thinned out in many, many cases so we can provide that oak resource that provides so much to us as Iowans. So, when we thin these out, we're going to allow more sunlight to hit the residual trees, and if oak and walnut is your primary management objective, that's a good thing. But also, the sunlight, the soil moisture, the nutrients available in the soil are fixed on a given site. So a lot of our woodlands, because of that passive management, are what we call overstocked. They're too crowded. So if you look at a tree ring, you'll have these little tiny trees that are quite old because they're just not growing very fast. And when forests are stagnant like that, they're more prone to wind damage, pests and disease, climate shifts, all that kind of stuff. So thinning these species out is going to do a lot of good things, not just for water quality in our bioreactors, but for forest health and resilience overall. Another thing too, a big driver of this project is the market. So this is a beautiful white wood. Some of the other species we're looking at for this project, such as ash and hickory, both very light colored woods, beautiful woods, a lot of uses. They're just they don't have that market value right now that oak and walnut do. So if we can increase their market value by having them being effective use in bioreactors, that may encourage more thinning, more active forest management working with foresters, and a boost to forest health. So Michelle and I will talk a little bit later about how do we get the forestry crew and the water quality crew together to source this material.
So you may wonder, how did Dr. Beck and I first get connected, and it actually happened when he was a graduate student and I was a associate professor at the time, and I was his mentor for preparing the future faculty program. And so through that process, we had the chance to start talking about our different research areas. He came and toured my lab spaces. We went out to the field together, and we started thinking about how we might be able to work together. So then when Billy was hired as an assistant professor at Iowa State, we started our first collaboration.
That's what I love about land-grant universities especially, is just the collaboration potential. Forestry and agricultural and biosystems engineering, like together, water and trees, it's really, really cool. So this actually all started with the first year Honors Mentor Program project. They hooked me up with a student, Celia Delury, who's now graduated, now a professional working on her PE. I gave her a list of things that combine trees and water quality, and she picked out wood chip bioreactors. So I said, okay, I know someone who does that. Yeah. I know someone who has lab space for that. So we started thinking about, from the forestry side of things, what are some species like we talked about before that could benefit if we removed them sustainably from our woodlands, but also don't have a big market value. Could we see if they perform better and give bioreactors a more consistent performance at perhaps a lower cost? So we set up these column mini bioreactors in the lab. We ran them for about 5-6 months.
During COVID.
Yeah. During COVID. We had to get the special pass to get in there.
One person at a time.
One person at a time in the lab. So we did that for about 6 months, and we measured obviously nitrate removal, dissolved phosphorus removal, greenhouse gas emissions, DO, things like that. And there was a significant difference between the species that we tested. So we thought, hey, let's blow this up, let's apply for more funding and get these out into the field and do more research to get to the root of what, no pun intended, get to the root of what's driving this performance with the different wood species. So
yeah, and so that's really given us the chance to build up some of the science in this space. Can we improve the nitrate removal potential of these wood chip bioreactors by using select carbon sources? And how does that tie into more of the engineering aspect? How much, the residence time is? How long does a drop of water need to stay into a bioreactor before complete denitrification can occur? So that's when the nitrate comes into the bioreactor. The microbial community that's in the bioreactor works to first make the carbon or the wood available to the microorganisms that do the real work, which is converting that nitrate to nitrogen gas. And so how long does that water need to stay in the bioreactor to make sure that we're not producing pollutant swapping or creating a greenhouse gas emissions in our attempt to remove the nitrate? Okay, so one of our challenges in getting the wood chip bioreactors installed to scale, so the large number of bioreactors that we'd like to see installed in the landscape, is that there's not a lot of trees when you drive around the state of Iowa, especially kind of the central part of the state. And so that was another conversation piece with Billy, is would we be able to have the wood resources in the state of Iowa to continue and to expand the installation of the wood chip bioreactors? Just another thing that we see, we want to try and get the cost of these conservation practices down, and the wood chips are a pretty significant piece of the installation, the overall installation cost of the wood chip bioreactors. But Billy, can you talk to us about the wood resources across the state of Iowa?
Yeah, and honestly, I had a little bit of a panic moment when we started talking about this project. I was like, are there enough trees in the state of Iowa to fuel the X 100,000 of bioreactors out there? So I looked up forest inventory and analysis data, which is U.S. Forest Service data. They monitor the growth and change of our woodlands over time. And yes, for these specific species that we're focusing on in this project, both species and size classes, there were enough in the state of Iowa to fuel these hundreds of thousands of bioreactors. And again, we're not talking about going out and just plundering the woodlands for these species. They need to be removed sustainably under the guidance of a professional forester, but they are out there. And in addition to that, another big question we had was, how do we get the foresters and the loggers in touch with the water quality professionals to source these things? Because the timing of both groups is a little bit different. They both have different timelines. And hopefully with that streamlined network, that forest to farm network, we're going to help drop down the cost of these practices.
Yeah, so I think we're really looking at how can we connect these two different groups of people who have very aligned objectives. When you think about environmental improvement, sustainability, protected ecosystems, those are goals that water quality professionals would like to see, as well as those who are involved with forestry management. So we definitely want to think about this from the Iowa perspective. When we're looking at the cost of the wood chip bioreactor, the wood chips are one of the more expensive components. And then if you add in shipping costs, trying to bring in wood from across the state or from other states, that's going to be prohibitive to moving forward with bioreactor installation.
And two, you know, big picture, if we get more forest management on the ground because of this project, that's more jobs in rural areas, that's opportunities for young consultants and forestry contractors to get more work, more jobs for the logging industry. It's just a win-win all around.
We're going to put a plug in for our next virtual field day. That will be March 7th, 2024 at 1 p.m. We will be exploring sustainable intensification on Iowa's landscape through relay intercropping. So that should be a really great virtual field day. So please tune into that. Otherwise, we're going to go ahead and get started with some questions for Billy and Michelle. Let's start off with, so we've got a few questions that came in. So how will we get wood chips without fossil fuel chippers? Is one question that came in. I don't know if Billy or Michelle, which one do you want to take that?
Beavers? I don't know. So I mean, that's a good question. I mean, a lot of the things we do around the state are reliant on fossil fuels. So that's a good question. I don't have an answer to that. So.
Yeah.
But I guess one kind of offset on that is you know, when we thin these woodlands, and forestry goes way beyond thinning. This is just one practice that is the toolkit of a professional forester to promote forest vigor and resilience. So we often cut and kill trees in forestry, but we are by no means they're always done sustainably under the guidance of a professional forester to achieve the landowner's goals. So again, like, we're not going out and saying, let's go hunt down these 3 species and remove them from our woodlands. They're often removed as part of a forest management plan for achievement of landowner goals. But back to my point, when you do that, because the resources on a site are fixed, when you do thin things out and encourage growth of desirable, for the landowner's management objective, desirable species, those species do grow faster. They sequester carbon at a higher rate, and that leads to higher masses of carbon stored over time. So there's kind of one carbon offset of this project.
Yeah, and I would also add that, as we're going to talk a little bit more in the next segment about different types of wood chips and different chipping options, but if we can get wood chips available more locally, whether it's a different size or differently chipped type of wood, that can help reduce transportation cost. And so there would be another potential offset for fossil fuels.
Great. So somebody asked, have you considered invasive trees? So this person's from Southern Indiana, and they have a huge amount of, I believe, Paulina, and I'm not totally sure how to pronounce these tree names, but some invasive species. So they're curious if you've looked into using invasive species for wood chips for bioreactors.
I think, is it Royal Polonia, the princess tree?
That could be.
Yeah, the leaf is like as big as a car hood. Yeah, it's like, okay. I can take a first stab, Michelle, unless you want to. So first things first, yes, that'd be great. A lot of our invasive woodland species are small, they're multi-stemmed, and they just don't have a lot of return value, I guess, if I could say that for lack of a better term, of harvesting them. So like a honeysuckle bush could take you I don't know, 5 minutes to cut down or whatever, but the wood volume return would not be there. It's very, very small versus cutting, you know, a 14-inch hackberry down. So that's one issue. One tree that may be a potential candidate would be white mulberry. So we have a red native mulberry, but this is white mulberry. It does have a tree form. it's not as large, doesn't get really as large typically as like hackberry or some of the other species we're looking at. But that is one species that we've considered for future investigation. So, but no, if we could somehow utilize those, it'd be great. So I think the size is an issue.
So somebody asked if biochar would make a bioreactor work even more efficiently, and I don't know if this is up your alley, but
I have had a student look at biochar, and it's kind of funny. This is a question that we get a lot. And so we did do a lab-based study, so nothing actually out into the field, but we looked at different sources of biochar. So whether it was sourced from grass, from a softwood versus a hardwood, and then we looked at a range of different pyrolysis temperatures to create, I think we had about 9 different products. And just at the batch scale, we were not able to see improved nitrate removal when we added the biochar. So, it was a small study, it was a lab study, but it hasn't been something that we've been able to kind of consistently see improved removal from the addition of biochar to a wood chip bioreactor. If you were to only use the biochar, there's some hydraulic properties that would come into play. It's typically a pretty fine material unless you go ahead and get it pelletized, which then increases the cost. And it also is, and so there's a big chance that you could have clogging, short circuiting, some different of those flow properties would be kind of difficult to address with biochar. So I know there is some published literature that shows benefits of biochar. It's just not something that we've been able to consistently reproduce in the lab.
so are there any negative impacts of wood chip bioreactors, especially when you jump them up to like a field size scale from a lab scale?
Yeah, so the biggest question that we do get is about the production of methyl mercury. So if you have anoxic, conditions where water is sitting in a wood chip bioreactor for a long period of time, there is the potential of methyl mercury production. But the good news is that the NRCS design standard is requiring a small a drain at the bottom of the orifice at the outlet of bioreactors. So that's worked into all bioreactor designs. And some work that we did in some of our field sites has shown that the potential for methyl mercury production would occur at a longer residence time than would occur than the amount of time that a drop of water would stay in a bioreactor when it is allowed to drain gravimetrically with the presence of that orifice. So that is one thing that we hear a lot about, but we do feel like that design standard change has helped to offset concerns that could occur because of methyl mercury. And then the other thing that we've done a fair amount of monitoring is the potential for greenhouse gas production. So I think we mentioned that, we don't want to, in the process of removing nitrate from the drainage water, create conditions where you have a potential for flushes of nitrous oxide or methane. And the work that we have done does show that you don't want your residence time to be too short. So if the water is only in the bioreactor for say like 2 hours, it is then possible that you have incomplete denitrification. And so you could have dissolved gases that are discharged from the bioreactor. That doesn't necessarily mean that those gases are automatically, or dissolved gases automatically, off gas into the environment, but it does mean that there's that potential. The other potential is, of course, that the denitrification continues in the stream environment, and we know that takes place as well. So, there are those concerns, but with the science that's been taking place over the past 10 years, we do kind of understand some design guidelines that we can provide to help prevent the production of any other different pollutants.
So somebody asked if you could expand on what types of trees are currently being used, species, and also what like size of chips are currently common in Iowa and Iowa's wood chip bioreactors.
Do you want to hit the chip size, Michelle?
Yeah, so the design standard is 1 inch, and that could be in any direction. So right now, we are targeting at least a 1 inch in one direction, and that is the NRCS guidelines, and that standard is in place to allow for good flow through the bioreactor for a longer period of time. Then you can talk, Billy, about the wood species that are used.
Yeah, so when we started this, Celia and I we had some hypotheses. We wanted to see which species physiologically would work better, but also we wanted to, pick that list based on species that were commonly thinned, commonly removed in forest stewardship practices, and or kind of had a low market value that really didn't encourage landowners to seek out a forester and start talking about, even though if timber might not be their ultimate goal, just kind of start the conversation about sustainable forest management. So we started out with a density gradient of wood. So cottonwood, very, very low density, hackberry, kind of next higher density, getting into hickory, which is even higher density. I'm sorry, hard maple, like sugar maple and black maple. And then finally, the densest of our little list there was hickory. So bitternut hickory and shagbark hickory. So our density hypothesis didn't hold true. So actually, hackberry, we'll talk about this in a bit. Hackberry and hickory performed the best as far as nitrate removal in our reactors. And honestly, we kind of scratched our heads on what did these two have in common that would, what characteristic did they share that may be a key to performance? And we're actually going to investigate that further in the future. I guess spoiler alert. But the one thing that they did have in common was they had a ring porous vascular distribution. So the veins of a tree, if you look at a tree ring, the little holes or the pores, the cross section of the veins, if you want to put it in human terms, are arranged a different way in ring porous species versus what they call diffuse porous species. And if you really want to know that, I got some pictures I can share with y'all. But that was the two. So the physiology, the arrangement of wood in the tree matrix was the two things that those shared in common. So that's one thing that we kind of thought about how that may impact performance, and then one thing that we're going to kind of test in our future efforts there. So a lot of our tree species out there in Iowa are diffuse porous, but there are a number of ring porous species as well. Another thing that we'll probably get into in a second is extractives. So if you look at the heartwood and the sapwood of a tree, and I've got a picture of that if you want to see that up close. The heartwood doesn't conduct any sap; it's kind of dead, but it does house a number of cocktail of chemicals that we, as a catch-all, call extractives. So these are tannins and fats and lipids and resins and oils, and all these things are unique. Each species has a unique cocktail that produces like the coveted heartwood color of black walnut, the great smell of cedar, and rot resistance. So maybe we're thinking that that chemical cocktail could impact A, the microbiome in the bioreactor, and then B, the durability of these chips in the bioreactor as well. So yeah, I think I went on a little bit too long there, but we're on kind of on the cusp of really diving into what is making these species perform differently.
Yeah, so somebody asked if you have looked into or thought about like recycling wood, such as like pallets or other like ground up wood materials as use in a bioreactor.
Well, I can kind of briefly say we do have not necessarily recycled wood, I guess, but more of the tub grinder woods that municipalities will typically have available in like a free mulch pile. So we are going to look at that in the lab. Those can work quite well. Part of it may be additional surface area for more of that microbial community to inhabit. But I think, Billy, with older woods, we're thinking that maybe wouldn't be quite as effective.
Yeah, and another thing too is I'm kind of a weirdo. Maybe some of you all on the webinar today can share this with me, but I pick up pallets on the side of the road. for using around my place. And if you look at them, they're made up of like, I mean, 3, 4, 5, 6 different species. So they're definitely, I think, a source, but for scientific, for this project, it's just, I think there's too many variables in pallet wood. And also too, if you look at these bioreactors, the volume needed is quite massive, shockingly massive when we did the math and did some tests. So there's not a lot of volume in a single pallet, if that makes sense. So, but no, I mean, that's a potential. It's always good to reuse. So,
So somebody asked, are there elements for protecting habitat and wetlands and things like that when we're considering like doing some thinning and clearing in forested areas? What considerations should a person think about before doing that?
so wetlands specifically, or I can rattle off some
Kind
just
of
general
habitat and wetlands. It's kind of what they both of them together, I guess. So
Well, I'd say the main push I think that I'd like to convey today is that, I mean, I'd say a lot of timber sales out there are not conducted under the guidance of a professional forester. So working with a professional forester to set up that harvest, it needs to be the right time to harvest to achieve your forest management goals, economic and ecological goals. And then B, that forester can work with you to help ensure that that harvest has minimal impact. And one thing I always recommend to folks, and actually we're making a new publication right now, is to have a timber sale contract in place with the cutter in that situation. And within that timber sale contract, you can list specific stipulations on how to minimize impact to that logged or that cut area. And that could be placement of roads, that could be avoiding certain areas, some certain sensitive areas such as slopes, wetlands, things like that. Timing of the year, making sure that is if there's an ecological issue like there's a bat habitat, kind of window, there's an oak wilt window to avoid for harvest. Setting out all those stipulations and being very clear is probably the umbrella suggestion I would have for that concern. So.
awesome. So for the sake of time, we're going to go ahead and move into our next video, and we'll continue to answer questions after this next video. So if you have any more questions, go ahead and throw them in the chat.
I'm going to put a link out real quick, Mitch. I talked about forest succession. So for time today, in this video, I do a little crash course on forest succession and the overall woodlands, our woodland resource in Iowa. So yeah, sourcing these chips is going to be really important. That's why we're developing this network between the forestry professionals and the water quality folks. And obviously keeping that source within Iowa. There's large scale, logging and forest management projects going on across the state on state land in winter. As I drive and meet with folks across the state of Iowa, many producers own chunks of timber that just aren't managed. Again, they're passively managed. So a lot of times they have these shade tolerant species building up in the understory, which is fine, but that could be a great source of local carbon media for the reactors.
So our lab experiments, we tested some of these shade-tolerant species of trees and looked at how they performed in comparison to each other, and then also in comparison to some mixed wood chips, and actually found that the hackberry was one of our best performing species. So then we need to think about how do we chip these, and can we use a variety of different chipping methods in order to be able to get trees from many different sources, or wood chips from many different sources. And so right now in the lab, we're in the process of testing different chip sizes. So different chippers or different types of grinders will produce different sizes of wood chips. They may look like, kind of the traditional wood chip that we typically think of for a wood chip bioreactor, but there's also chippers that are smaller in size, so they tend to produce smaller wood chips that don't yet meet the NRCS standard. There's also tub grinders that produce more of that shredded wood material that you can often get from a municipality for free to use in landscaping around your house. And so with these different sources of chippers and different types of wood, we're hoping that we can provide a more readily available wood source for the wood chip bioreactors.
Yeah, and once we finalize or get the answers on the chip sizes, that's going to be huge in selecting our species. As you can imagine, different wood species have different wood properties, and they chip up very differently. So if we need to match a certain chip size, some of these species need to be screened out, and that's an extra step in the processing that adds costs.
Yeah, in some of our screening experiments, we're losing 40 to 60% of the original material because those chips are too small, and so then we're not able to use those in the bioreactors. But some preliminary experiments that we've done in our labs and some other universities are showing that maybe the size of the wood chip is not as important. And so that's why we really want to explore what the impact of these smaller chip sizes is on nitrate removal, but also the hydraulic properties, as well as how water can flow through the bioreactor, and if the bioreactor has the same longevity, if it can still expect its lifespan to be between 10 and 15 years.
So with the chips, we've noticed that a lot of species chip up very differently, and there's been a lot of kind of requests for us to come grab people's very old dead ash trees. So that's probably not ideal because ash degrades, even when standing, the wood quality degrades and the properties change very quickly when standing in the wood. So we really like fresh trees to be ground up or chipped up and used for this process. You mentioned chemicals in there. So all these species are very different. They're heartwood. The center of the stem contains a mixture, a unique cocktail for each species of fats and tannins and resins, and that gives wood its unique durability, its unique color, its unique smell. So think about the beautiful color of black walnut heartwood or the smell of cedar. Those are those chemicals housed in the heartwood, and we're interested maybe in the future, well now, do those chemicals influence the performance and the durability of the chips? But in the future, there's a huge knowledge gap as far as those wood extractives.
Yeah, all those extractives are, slowly released with time, and they're going to have an impact on the microbial community. So how do the microorganisms respond to the presence of these different extractives? And do some of them actually stimulate the denitrifying community? We're really interested to learn more about that. And then, of course, by knowing what combinations of extractives from different wood sources, we can then choose the best wood chips for improving the performance of the wood chip bioreactors.
So these are the three species that we're focusing on in this project. We've got hackberry, ash, and hickory. This is shagbark hickory in this case. Three great wood species, beautiful woods, but you notice that they're all light in color. I'll kind of zhuzh them up here. But this light color, unfortunately, is not really in these days for cabinetry and flooring and whatnot. I wish it was, but that's kind of what is leading to their lower market value right now, as opposed to, got this in my pocket, black walnut, which is coveted globally. I mean, we grow the best, highest quality walnut on planet Earth here in Iowa. You can just see the color differences, and that's really why these are a little bit, significantly lower in market value. So, these are also very common in our woodlands. Ash obviously is on the decline, but hackberry, hickory, again, we talked about, they build up in the understory. So there's a decent supply out there. And if we add some value to them as far as bioreactors, hopefully we can encourage more farmers and more landowners to get involved in active forest management with a professional forester. So right now with the project, it's exciting on my end because harvest is going to start ramping up here in the fall and winter. We're working with a number of timber buyers, loggers, and professional foresters around the state to obtain the volume of logs that we need to process to fuel the number of these field scale bioreactors that we're going to be putting in for this effort.
Yeah, so we have a total of 26 bioreactors that we're working to get installed over the next couple of years. Different wood chip sizes. We're going to use small chips. We're going to use the shredded chip material. We'll also be using the standard chip sizes, but of some of these woods that Billy has been talking about, such as the hickory, the hackberry, the ash. And so really exciting time as we work through the design. We've been collaborating with different counties locally to try and assist with the design and securing the wood and then getting that installed in bioreactors in the area.
Iowa's got 3 million acres of woodlands. We've got water quality issues. We could really do a lot to enhance water quality in our forest, our precious forest resource in the state. And I'm really excited about connecting the ag and forestry communities for the benefit of both.
All right, so go ahead and put any other questions you have in the chat. I'm going to go over some other things here. So if you are watching today to get your Certified Crop Advisor certification, go ahead and email Alena Whitaker, that's ALENAW, at IA State by 5 p.m. Today with your name, the name you entered the webinar or the virtual field day with, and your CCA number. So if you are interested in a wetland, an oxbow, bioreactor, or saturated buffer, you can send your name, email, phone number to ilf@iastate.edu, and we'll help connect you with somebody in the Iowa Department of Ag and Land Stewardship. I urge you to go take our voluntary demographic survey. If you've watched a virtual field day live, you don't need to fill it out again. We just need one for 2024, but I urge you to go fill that out. And finally, we will be hosting another virtual field day on March 7th at 1 p.m. This will be about exploring sustainable intensification on Iowa's landscape through relay intercropping. So I urge you to go ahead and watch that. So moving back to our questions. Looks like we've got quite a few in. So let's see what we've got. So one question we got in was, will you be working with NRCS to kind of figure out wood chip requirements, and are wood chip requirements currently pretty set in stone, or is there variability with the size and species of wood chips that are allowed to be used in bioreactors currently? And then are you going to work with them to change that or work around that?
Yeah, NRCS has been a fantastic partner. First of all, they funded the project through Iowa SIG as well as the IPC program, and we do work directly with their engineering staff. So for the tub ground wood, we did not have to do anything special because it already meets kind of that wood size requirement. But for the small chip bioreactors, so smaller scale chippers that may be more common throughout the state, we did have to get a variance from NRCS, and that has already been approved. So they're definitely in the loop, and I know they're also looking forward to seeing the results of these studies.
Awesome. So somebody asked, how long, or are you looking at the length of how long these wood chips will last in different bioreactors, depending on species? Or are you seeing some wood chips lasting longer than others?
Well, that's certainly a question we hope to be able to answer. We're really early stage with this. The lab studies that Billy and his team ran were for 6 months or so, and then we're just getting started as far as getting these bioreactors designed and installed. So we do have budget to monitor for the next 3 to 4 years, and then of course we'll hopefully try to continue that beyond that time period. But I think more coming soon on that. And then also, I think something that could play into this is when we're talking about the extractives and trying to really understand what comes out of that bioreactor over time and how it impacts the microbial community. I think more of that basic science in this space could also help us to understand the longevity of different types of wood sources.
Yeah, so somebody asked, do denitrifying rates remain pretty steady across the lifespan of a bioreactor, or do they usually kind of wane off as the age of the bioreactor goes on?
Yeah, we definitely see increased nitrate removal early. So, a fresh wood chip bioreactor is going to have more readily available carbon, which can really stimulate that denitrification community. And so we do often see the best performance right after the bioreactor is installed. And then with time, it does tend to stabilize. There's other factors that can impact, especially temperature. We'll see during warmer water temperatures that also, microbes are much more active during warmer temperatures, and so we'll see more nitrate removal during those times. But then, yeah, we do tend to see kind of a decline. But it is really interesting because there are some bioreactors that just have never worked very well. We will get a batch of wood chips into our lab and do the same column experiments that we always do, and we may only see 5 to 15% nitrate removal. And then another batch may have 30% nitrate removal under very similar conditions. So that's really, we've been looking at the engineering design, the residence time, the effluent nitrate, the temperature, but we really weren't able to explain why would we see these variations. And so that's when we really started to think about the carbon source and try to better understand, what carbon materials are going to work best to, get the highest nitrate removal on a per unit basis for the investment in these bioreactors.
Yeah, so another question we got in, is there a range you're targeting for, or as far as maturity of trees? Or is it any age of tree that works well for wood chips for a bioreactor? Um, yeah.
Yeah, good question. I always say it's really hard to tell a tree's age by its size. And I actually have a pretty cool slide. If we got time, I can share that. But I guess a couple things to consider is most, even the industrial, what I'll call industrial chippers that you saw in that video could only take trees up to a certain size. So that's one thing to consider. A second thing is when we harvest these, we really want to make sure we're meeting the landowner goals, both ecologically and economically. So that plays a role too. You really have to know, is this the right time to harvest, or is this the right time to thin? It's not just about going out and grabbing specific sizes of trees. Another thing to consider is that the heartwood and sapwood of trees have very different characteristics and may impact bioreactor performance based on the ratio of heartwood to sapwood. So as a tree gets larger, it always has the same number of sapwood rings, but the heartwood keeps adding over time. So that's another thing to consider. So for example, a very, very young tree would be almost exclusively sapwood. And as it gets older, when it meets that threshold of its, the number of sapwood rings that species has, it's going to keep adding heartwood after that. So, and honestly, a lot of times when we need to thin our woodlands to provide sunlight to more desirable species, we're talking about pole-sized timber. So pole-sized timber is something like, think of a 10-inch, 12-inch, up to something like a 14, 15, 16, even 17-inch diameter tree. So above that, you get into the 20s. That's when you're going to start talking about saw timber. You get up into the mid 20s, you can start talking about veneer and things like that. But we're kind of talking about the teens, really, as the species that are going to give us a good return if we spend the time getting out there and cutting them. So.
Yeah. So Michelle, could you go over some of the typical maintenance requirements for bioreactors?
Yeah, that's one thing that we really like about the wood chip bioreactor is that in general, it shouldn't require too much maintenance. So these are installed at the edge of the field between the cropland, and then oftentimes will discharge directly into a stream, but sometimes they're located inline, and so you may have a bypass around the bioreactor and then it'll discharge back into a drainage line. But what we do like to see is the adjusting the water level in the wells so that during early spring conditions, we don't want to risk backing water up into a crop field. We want to make sure that farmers can get into the field to work the land to plant as they need. And so early spring may be a time when we have higher flows through the tile line, and it may exceed the capacity of the bioreactor. So that case, you would adjust kind of that inlet structure to allow for some water to bypass around the bioreactor. But then as it starts to dry out through the summer months, you could then adjust those wells again to put more water through the bioreactor. So, that's really the only requirement is to adjust those, the stilling wells so that it would allow kind of optimize the amount of water that goes into the bioreactor. Maintenance on a year-to-year basis, I can't really think of a whole lot. Sometimes we do try to mow the area. And then really you can't see the bioreactor except for the inlet and outlet structures.
So another question, somebody asked if there's any way to avoid or reduce the use of plastic in bioreactors. They seem to be referencing like the liners, bioreactors and the wood chips.
Um, not, I'm trying to think of, I'm not real, this isn't a great question for me to be able to answer. I'm not real familiar with any systems that don't have that liner. We do put a liner over the top to try and separate out the wood chips from the topsoil or that soil cap. We don't want soil to get into the bioreactor and to potentially clog it. And so that's the reason that we do put that geotextile fabric on the top. And I mean, that's a great question. Certainly something to think about. But I do think we are putting liners in most of our systems.
Somebody asked if you can kind of go over the process of replacing wood chips. So after 10 years or whenever the wood chips are kind of out of used all up, what is the process of going in and replacing that in the bioreactor?
Yeah, a recharge. And so it's a pretty simple process. We're typically looking at, just getting an excavator in place to dig out the wood chips. Those wood chips that are used are often just land applied, so they're not something that's a material that has to be shipped offsite or anything. It could often be just applied to kind of nearby cropland, or if there's a access area where some wood chips would be helpful, they can be applied there. And then we would just bring in a fresh batch of wood chips. Sometimes we would likely want to check that internal plumbing. So at the inlet, at the upstream end of a bioreactor, there's a distribution pipe that's often a plastic or PVC that helps to spread the water out so that it flows into the bioreactor throughout the entire width. So we'd want to, check that internal plumbing and make sure that that's still in good shape. So there could be some replacement there. But then otherwise you would just bring in the fresh wood chips and then put the soil cap back on top. So I think it's a pretty straightforward process.
Great. So it looks like most of the questions we got in today. So if anybody has any further questions, you can go ahead and put those in the chat. Once again, if you are watching today for a CCA credit, please go ahead and email Alena Whitaker, that's ALENAW at iastate.edu by 5 p.m. today with your name, the name you entered the virtual field day with, and your CCA number. Also, go ahead and watch or join our virtual field day on March 7th when we explore sustainability and intensification on Iowa's landscape through relay intercropping. We got another question in. Which wood is your favorite for a bioreactor system?
I guess the one that's easily obtainable and has the highest performance. So, I mean, to date, like I said, hackberry and hickory, which may include bitternut hickory or shagbark, perform the best in the lab. And between those two, honestly, I actually have if we got a second, I have a slide here, but it's not really necessary. Hickory being more dense, when chipped up, it almost shatters into larger pieces. Whereas hackberry has a lower density, it has a more uniform and smaller chip size. So we talked about screening as an added step in the whole process and adding a cost to that process. If we get a high performing species that we don't necessarily need to do a lot of screening with, then perhaps that may be an answer. I'd say overall hackberry is a little bit more abundant than bitternut hickory and shagbark, but I think I guess this kind of hits the point that we're looking at too, is maybe there's like a recipe or a mixture, or say we add 10% of one species into the standard wood chips, or 20% for the characteristics that they bring. So at present, we've got a couple contenders, but we really want to investigate that further. So
Yeah, we actually have a list of 30 woods that we'd like to, no time and money limits. We've got quite a list of woods we'd like to explore.
One wild one is Osage orange. It's not native, but you might know this as the hedgerow tree with the big hedge apples that are bright green, but it's almost rot resistant. That might be a very, very interesting species to investigate. Maybe we don't put 100% in there, but maybe a 10% shot might give it some added durability or performance. So wood is very different across species. It's quite interesting.
Yeah, so another question we just got in. So if you have field scale bioreactors operating now, how do they compare to the lab scale? Are they pretty comparable, or are you seeing some differences in lab scale versus field scale experiments or trials?
Yeah, that's a great question. And it's really interesting because we see such variation in our lab scale column studies that we've done. And then we also see variation in our in the field monitoring that we've done. So I was actually just looking at I think it's like a 6 to 60% range is kind of the removal efficiency for wood chip bioreactors. So that performance range is really large. And the one thing that we just really haven't controlled for is that source, that wood source. We start an experiment, we go and get a batch of wood chips, and then 2 years later we get a new grant, so we go get another batch of wood chips. And we haven't in the past worked with forester to help us understand, what are the carbon sources and the different types of woods that we've been using in our experiments. And so yeah, we're seeing a ton of variation. That's the shorter answer. And I really hope that this can provide some real insight into what's going on and what those differences are caused by.
Awesome. Well, that's about all the time we have for today. So thank you everybody for tuning into our virtual field day today. Thank you, Billy and Michelle, for helping us out and answering some questions. So thank you all for tuning in. Hopefully we'll see you all on March 7th.
Thanks, everyone.
Thanks.
Do you want us to stick around, Mitch, or are we?
You're good to go. Thank you guys for
All right.
joining us
Thanks,
today
Mitch.
and answering all those questions. So
Yeah, a lot of great questions.
yeah, there was lots of questions. So no, thank you guys.
Thank you. Thanks, Michelle.
Awesome. See you later.
Bye.
Bye-bye.